This video is about the execute process operator. This operator lets you run one RapidMiner process from another. This is extremely useful because it allows functionality to be encapsulated into modular building blocks, which facilitates efficient sharing and reuse. Processes to be run can be parameterized using macros and can operate from inputs such as example sets, and this gives tremendous flexibility. Running processes in this way is also a stepping stone to using processes exposed as service endpoints in RapidMiner server. Essentially, once a process can be run from the execute process operator, it's pretty straightforward to expose it as a service in RapidMiner server. So, what we'll cover, we'll look in detail at a process that we're actually going to execute, then we'll run it, or execute it or run it. Then we'll look at passing data as input using the useInput parameter. Then we'll look at outputs and how they're affected by the storeOutput parameter. It's possible to get metadata from the executed process, which is quite handy. We'll look at that briefly. Then we'll look at macros and how you pass them to the process to be executed, probably the most important thing actually. And then finally we'll look at a brief discussion of how to get from a process to a RapidMiner server web service. Okay, so let's firstly look at the process that we're going to execute, which is extremely simple actually. It's got two operators. One's print to console, which basically prints to the log, which is this window here, and it basically outputs the value of the macro, which is called mode. And I put some little asterisks around it just to make it show up a bit better. That print to console operator takes an input, we'll look at where that comes from in a moment, and just passes that straight through as an output, as the second output. This operator is generate data. It generates 100 examples with random data in. If we look then at the input, that's actually defined in the context, which is here. And basically you can point to repositories in order to automatically connect up the input. So in this case I've pointed the golf sample data as this first input. So what that means is when this process runs, the golf data is passed to it. When it finishes, it actually also outputs two example sets into the repository. I've given them very creative names of out1 and out2. And the final thing in the context, you can define a macro. And so I've defined one called mode, and I've set it to the value 1. So if we run this, what we should see is two example sets. Sure enough, we've got the golf data here, and we've got some random data here. Well, also you can see here in the log view, it's printed out the value 1 between two asterisks, between two sets of asterisks to be precise. And if we look at the macro view, you can see here is the macro mode, and it's set to the value 1. So that's all working very well. So if we now go back to the first process which we're going to use actually to execute that one. So the actual process execution is done in this operator here, but let's briefly look at the ones around it. So we're retrieving the iris dataset from the samples in the repository. We're passing that as an input to the execute process operator here. And then there are two outputs because we happen to know there are two outputs from the process we're executing. And I'm just going to illustrate the metadata propagation using the select attributes operators here. So if we now look at the actual execute process operator in detail, we're seeing firstly here is the process we're going to execute. It happens to be in my repository. It's called executed process. Now if for some reason that doesn't show up, you don't have that, basically it's in the comments for this operator. So if we go show view comment, if you copy this entire XML and simply start a new process and paste this XML into the XML window of that new process, you will get a process that you can execute. And then as long as you save it with a name that you know the name and put that value in here, everything will join up. Okay, so this execute process operator will obviously execute that one there, and I have set the various parameters. So I'm using input, I'm storing output, I'm propagating metadata, cache process, I don't worry about that one too much, and I have a macro set up, and it's a macro called mode, and it has the value 2. Okay, so if I run this, let's see what happens. So now what's happened is, again, there are two example sets rather, and one of them is the random data from before, but the first one is actually the iris data set, if you recognize this. So what that means is the input has overridden what the executed process has as its default. If we deselect use input and run it again, this time it's the golf data set. So in this situation, the input has been ignored basically. So whenever the default is in the executed process has been used. Okay. If we also look at the log, you can see that it's logged the value 2 here. So in other words, when it was executed, the value of the macro called mode was passed as a parameter. So in principle you can go on adding macros here, and there's a little check you can put in. You can make it fail if you define a macro it doesn't understand, and by that I mean if the executed process doesn't see the macro in its process context and you've provided it, then it'll blow a gasket. So that's what that one does. Cache process, I have to be honest, I've never really made that do anything other than not much at all. I'm sure that's very advanced. So now let's look at store output. So in this situation I'm setting store output to true, and you can see that if we go and look in the actual repository, out1 and out2 is the result of running the executed process, and trust me, it's 4:50 in the afternoon on a Saturday. If I delete those two and run the process again, we should see they've turned up. Go back to the design view. So running the process, executing the process has led to 2 data entries being placed in the repository. But if I change store output to false, delete them again, run it again, this time you still get example sets as output from the executed process itself, but now nothing gets written to the repository. So essentially what the store output parameter is doing is dictating whether the executed process is allowed actually to write to an external location, the repository. Propagating metadata, so this is quite nice because it means it can help you just be more efficient in your downstream processing. So looking at select attributes here, the first example set is just random data. So if we look at this, you can now see these are the attribute names of that, which is quite nice. So let's work that out from the context. And similarly, if we look at here, this is the golf data set. These are the attributes for that. Now it's quite interesting. Obviously, I'm not passing the golf data set in, so clearly it's probably a stretch too far to get it to look at the actual data that's being passed in rather than what's set as the default. But nonetheless, it's still quite handy to have metadata being propagated like this. So for example, if I set that to off and do select attributes, now there's nothing in the attributes list here. So in other words, it hasn't filled any of that in. Fair enough. Put that back. Okay, so let's just run it one more time. I'll just put everything back to normal and run it. So now we're going to see the random data plus the iris data set. Sure enough. So you can now see it's very easy just to execute processes. So now you can start to get to the point where you define your process and you define the macros and inputs that it requires, and then you can get them working and then have them as little building blocks that you can start to call. And it's extremely handy and just makes you go a lot quicker if you have a reasonably big process that you're trying to define. And then the final thing we'll look at is RapidMiner server. Now when you save a process in RapidMiner server, it's possible to expose it as a web service in its own right, and then RapidMiner server exposes an HTTP-like interface where you can do a simple GET, actually, just like go visit a web page, where you can, the act of visiting the web page with the name of the process in has the effect of running that process. And you can imagine, clearly, to make that really flexible, you need to pass parameters, and what you do basically is you define macros, and those macros become part of the query string that's issued when you invoke the HTTP GET. So think of it as you visit a web page with the name of the process, and then there are various name value pairs. For mode equals 2, for example, would set the macro mode to be 2. In addition, you can actually also pass, you can use an HTTP post like approach, and you can post files so that they actually get passed to the RapidMiner server environment, and then that file gets passed as an input potentially to the process to be executed. So you can see it's an extremely flexible way of firstly creating your process and getting it working. You get it working in this execute process context, and then when you're happy with it, you can just publish it, and it all just joins up and works really well actually. So it's extremely simple to get that going. So let's just go to one more run, and then I just run it one more time. We can look at the log as it executes. There we go, and you can convince yourself you can see what's going on. So there's the ARIS dataset, there's the random data, here's the log.